Hi, and welcome back to Antiformal. I'm Allison Johns. I am Pick and Hammer's archivist, and today I'm going to talk about my own research experiences within the newborn college that I experienced through the Honors College's FYRE program. But first, mineral of the day. So today's mineral is actually not a mineral, but it's fun, so I'm picking it anyway. Today we are talking about obsidian. So obsidian is a product of volcanism, and so it's a volcanic glass. So lava is ejected out of a volcano really fast, and it will sometimes, if it has a lot of silica in it, it will harden into this. So the reason that it's not considered a mineral is that it doesn't have a definite composition, and it doesn't have a structure, a crystal structure. So it's very amorphous, and it can definitely vary based on like the kind of minerals that are in the lava or the magma, which magma is underground, lava is above ground. So this one, you can actually see it has a lot of holes, so we call it vesicular. And so all those holes are actually bubbles where gas was inside the magma, and so when it cooled really fast, it still had these bubbles in it, and so it left it right in there. Sometimes you get a variety, and it is called snowflake obsidian. So it's the same thing, except it's got these little white spots on it, and so we call it snowflake obsidian. And those are actually little bitty patches of mineral called cristobalite. And so when you see that, it's the same general composition, just in general shape, but it has just a couple of little extra minerals in it. So obsidian, usually when you see a very dark igneous rock, you can say that it's what's known as mafic. So it has a lot of metals like magnesium and iron. But the thing about obsidian is that because it's glass, it has a very high silica content, and so it actually would be considered more felsic or intermediate. So felsic has a lot of silica and not a lot of those metals, and intermediate is in between. You may have seen before an obsidian arrowhead, and the reason that you have obsidian arrowheads is because it's glass, and so it breaks really easily into a very sharp point. So you can see that some pieces of obsidian have very clean breaks along lines that will come right to a point. So you should be careful when you're dealing with it not to accidentally cut yourself. So today, as I said before, I'm going to talk about my own research experiences with the Honors College FYRE program. So that stands for First Year Research Experience. And so if you're in the Honors College in the fall, you can apply and you pick. So different professors will give options, and they will say, I would like a student from FYRE, or I would like 2 or 3 students from FYRE to come do some work with me. And then you apply, and the professors will pick. And so my research was with Dr. Michael Sorrigan here in Newborn, and he does sedimentology. And so his primary field of research is on what's known as shell beds within Lake Tanganyika in Africa. There's a certain species of snail, and they're large snails, and so when they die, they leave their shells in this bed, and it's very important to the ecosystem. So because it's a primary piece of the sediment is these snail shells. So there are actually species, like certain species of fish, cichlids, that only live like in these shells. So like the females are much smaller, and they hide in the shells to protect themselves and the babies. The field of research that I was working in is called taphonomy. So taphonomy is the study of what happens to something after it dies. So my major is actually paleontology, and so it's really interesting to me to find out like what does happen, because it's a very important part of paleontology, because you find a lot of things that are like broken up, or like, so it's important to understand the processes and the mechanisms that might be affecting a sample between the time it dies and the time you're looking at it, which sometimes can be thousands or millions of years. And so basically the research that we did was based on trying to look at like general properties of samples of these shells from different depths and locations along the lake. And so by looking at different properties, you can sort of see general trends within the nature of the shells, because as sediment load increases within the water, so the amount of like sediment that's being dumped downstream, as that increases, which is because of human activity, as that increases, you're going to see these shells start getting buried more and more. And so if they're not there, then you all of a sudden lose an important part of your ecosystem. You lose a part of the sediment that all these things live in and around. And so you want to take a look and you want to see what's going on with them. Lake Tanganyika is what's known as a rift lake. So it's opening, it's widening all the time because of like plate divergence. So it's being pulled apart, it's being widened, it's creating this rift, which is filling up with water, and so that's the lake. So it has a lot of like sedimentary turbulence, and it's always changing and growing, and so it's very important and interesting to look at like what's happening here, because it's like we're watching very slowly these geologic processes happen, and we're seeing how it's affecting all these snails. The snails are called neothelma, and they're rather large as snails go. They're not huge, but they're big enough that they cause like an actual impact in the environment. So all these shells create like a substrate naturally. And so another important thing to understand about these shells is that the shell that is secreted by a mollusk like a snail is going to be primarily carbonate based. So a lot of things like aragonite. When it encounters acid, it effervesces, which is just a fancy word for it bubbles up, it fizzes, and it goes away. It'll dissolve right away with an acid. And so as acidity increases within the lake, you're going to also start seeing the loss of these shells. It was definitely a really unique experience that I got to do, and I would highly recommend it to anyone who is interested. And if you're a freshman and you're in the honors college, definitely apply. Even if you don't see anything that you particularly is like exactly what you want to do, it's still a really good opportunity to go find something, and you don't have to continue on with whatever you do. It's a 1 semester commitment to go a few hours every week and to go do some research, and basically you also get to learn about the process of doing research. So you get to learn about how to work and how to collect your data and different ways to show your data, and you get to learn about organizing it when you do the poster presentation. So you make your charts and you report your findings and you explain like what does this mean in terms of like the broader picture, like because that's an important part of research, is that if I look at snail shells and I say, okay, these are really encrusted or these are really abraded, what does that mean? And so if I were to say find a sample that was heavily abraded, I might say there's a lot of waves or wind or some sort of a lot of activity over here that's causing all these shells to move around and scrape against each other. If you see a lot of darkening, you're going to say that that's a lot of high mineral content that's causing that. So it's really important to understand the context of your research also. So the 5 factors that we looked at on each shell were called, we looked at the encrustation, which is how like covered in this dirt and algae it is, so how crusty it is. Abrasion, so how much it's been like rubbing around against other shells, like with currents or whatever. Fragmentation, how much it's broken, so like some of them were complete, and some of them were very like little pieces. And then we looked at a couple of factors that were based on like minerals and stuff in the water, so reddening and blackening. Some of these compounds in the water, and this might be like algae or things, might turn it sort of a purpley red, or it might start getting black, like very dark. And so what I did was I would take a sample from a certain location. So I looked at 4 samples at the same depth from different locations across the lake. And then, so I took each shell, which was already processed, and I looked at it, and I went to a spreadsheet and I ranked it 0, 1, or 2 based on each of those factors. So 0 being none and 2 being like completely. So I would say this was very encrusted, so I give it a 2, and it was kind of fragmented, so give it a 1. No abrasion, give it a 0, and so on. And so I actually was able to arrange this data into what's called a ternary plot, so it's a graph, it's a triangle. And so you can look at it, and it's based on the percentage of the sample that is 0, 1, or 2. So you can look at a ternary plot and say the sample, with this specific sample, was like 30% not at all abraded, and 40% a lot abraded, and another 30% sort of in the middle. So the ternary diagrams that you create are pretty common in geology, measuring things within like 3 points, and they're a really good way to see easily if trends are consistent along something or if they vary. So if your points are all clustered together except for one, there's obviously something going on there that creates some kind of outlier. You can also see, so I had one sample where 2 of them had a decent amount of reddening and 2 of them had no reddening at all. So 2 of the samples are just all the way up in the top corner at the 0. And so it's a really easy way to say, oh, well, something's different here because they're not turning red. And so sort of one of the fun things about this class that I took, the FYRE program, is, well, first of all, you do a class where you listen to some like lectures about like other different research experiences, and you get to sort of meet a lot of other people who are also going through this program and who are also doing research for the first time and learning about it. And at the end of the program, you make a poster, so you make a big poster about your presentation, and then you get to go present it. So we all went down to the forum building and we hung up our posters on the walls. And then people came by and they asked about it, and so you got to sort of explain your research to people, and you got to meet a bunch of other people and see what all research they were doing, and there were snacks, and you could have like friends and family come. It was a really great experience that I would definitely recommend for other people. Especially if you're planning on going into a geoscience field, there's a lot of research and sample collecting and data gathering and analysis that happens. And so I think that going through this program really helped me to understand like what actually do you do. So sitting down with a bunch of samples and my computer with a spreadsheet and just going through and analyzing and categorizing all of these shells individually really, I think, helps me to show me like what do you actually do for research, because I think for a lot of people, a lot of students, research seems kind of daunting because it's not something you've been exposed to at all basically before college, and so all of a sudden people are saying you should do some research and you don't even know what you're doing. So an introductory program like this is really amazing for getting to find out like what is research, how do I do that, and I think it really helps you get your footing, and it helps you to show you how to do research, and helps to move you into like research later. So to things where you can even publish your own findings. Don't be afraid to go and talk to professors about studying research also, because most of them who do their own research, especially within the School of Geosciences, a lot of them have to do their own research, and a lot of them would love to have some help from a student who might help them process samples or just help them around the lab generally. So definitely reach out to anyone whose work sounds interesting to you and see if you can work with them. Yeah, so I got to make a lot of cool connections, and I really enjoyed getting to work with Dr. Sorigan on his work. I am planning to continue on working with him this year and in the future, and So every summer he actually goes out to Africa and he goes and collects samples and they process them and they work through them and then they ship them back here for research. So when I get to them, they're already processed, but out in the field you just have big buckets of snail shells and mud. I would really like to thank Dr. Sorgen for I'd like to thank Dr. Sorgen for working with me and allowing me to work with him, and because it was an amazing opportunity. I have really enjoyed getting to know him. And I would also like to thank Dr. Milos Savic, who is the head of the FYRE program currently. Our next meeting is next week. It's on October 12th at 6 p.m. in 1446 again. There will be food. Come down, say hi, get some dinner, meet some other people, come learn about what we've got going on in the future, learn about some events. As always, if you come to 2 events with us, you get a t-shirt for free. And that's pretty cool. So, I will see you all hopefully next week. And Antiformal will be back in November. Thank you so much.